Hello everyone, in this video we are going to be looking at solving problems using Pythagorean Theorem. So what I'd like you to do is get a piece of paper and a ruler, and I want you to use the corner of a page that we know it's exactly a right angle here. I want you to measure so many centimeters across, make it a nice whole number, and so many centimeters up, and then draw a line across and measure this distance here. And you're going to repeat that 2 more times. So you have 3 triangles where you know the measurements of A, B, and C. Once you've done that, I want you to fill out this table. So you're going to square the A, so A times A, B times B, C times C, and you're going to put that down for the 3 triangles that you created. So pause the video, draw and measure those 3 triangles, fill out this table, and then start up the video again when you're ready. Okay, now that you have your table filled out, I want you to see if you can see a pattern in your table between A, B, and C. Is there a pattern across your rows here in your 3 triangles? And what you should find is the same thing that a philosopher named Pythagoras found. He was able to prove that in every right triangle, it has to be a right triangle. Remember, that means that it has a right angle or an angle of 90 degrees. In these triangles, the square of the hypotenuse is equal to the square of the other 2 sides. You're like, what does that even mean? In other words, the area of A, so if we made a square out of the side of A, and made a square out of the side of B, and we found the area of those squares, those together would give us the area of C every time. So this square plus this square equals this square every time for right angle triangles. And if we think about finding the area of a square, really what we're doing is squaring the letters. So A squared, B squared, and C squared. So we get this formula, A squared plus B squared equals C squared. And if you look back to your table, you should see that these 2 numbers added together give you this number here. Now, if you had a decimal, funky sort of decimal number, it's possible it might be a little bit off if you weren't able to be exact, but it should be pretty close. And so if we know the length of 2 of the sides of a right triangle, we can use this relationship to find the 3rd side, the length of the 3rd side. So for example, here I have a triangle that's 3 centimeters by 4 centimeters, and I want to find side C. Now, side C is always the hypotenuse, or the side that is across from our right angle. A and B can switch. Those don't really matter. But C has to be your longest side, has to be the side that's across from your right angle in order for this relationship to work. It's the biggest square out of the 2, so it should always be the longest side. So if I want to find C, again, Pythagoras tells us if I make a square of this side, which would have an area of 9 centimeters, 3 times 3, make a square of this side, which would have an area of 16 centimeters, or 4 times 4, that those together should add up to give me my 3rd side, which is 25 centimeters squared. And what side length would give us 25 centimeters squared? Something times itself, or the square root, tells us 5 centimeters. Now let's look at that in terms of writing it with the formula. So I'm going to write out 3 squared plus 4 squared equals C squared. 3 squared is 9, 4 squared is 16, and if I add that together, that gives me 25. And to undo the square, we're going to do a square root in order to figure out what number times itself gets us to 25. So you're going to use the square root button on your calculator of 25, and you should get 5 centimeters. Let's look at another example here. So if I make a square out of this side, I get 225, 15 times 15. On this side, I get 64, 8 times 8. I add them together and I get 289. If I square root that, I get 17 centimeters. So let's look at that in the formula. I put 15 squared plus 8 squared, and it doesn't matter if you switch a and b. So it can be 8 squared plus 15 squared, 15 squared plus 8 squared. Either way, you'll get the same answer of 289. Then you're going to square root that to get 17 centimeters. Okay, so I want you to try to find the length of C and round your answer to the nearest tenth or 1 decimal place. So pause the video, try it out, and start it up again when you're ready. Okay, so here is our formula. I'm going to put 7 squared plus 5 squared. I get 49 plus 25, or 74, equals C squared. I'm going to square root 74, and I get 8.6 centimeters when you round to 1 decimal point. Now, what about if I don't want to find C? I know C, but I want to find side A or side B. Well, we can rearrange this formula to solve for any side. So here's my original formula. If I rearrange, I can do a squared equals c squared minus b squared, right? Because these two add together to give you this one. So this minus this or this will give you the other number. So I'm just going to rearrange this formula to get a squared equals c squared minus b squared. So now I can put my numbers in. 5 squared minus 4 squared. Again, c matters. It matters which one is c. It doesn't matter whether this is a or b, but this has to be c, so it has to come first. I get 25 minus 16, which is 9, and if I square root that, I get 3 centimeters. Okay, now let's find side B. We're going to round our answer to the nearest tenth. So I'm rearranging. I get c squared minus a squared. So I get 35 squared minus 10 squared. I square root that, and I get 33.5 centimeters. Okay, I want you to try this one. Round your answer to the nearest tenth. Pause the video and start it up again when you're ready. Okay, so here's our formula. We're going to rearrange it for B. I get 61 squared minus 60 squared. I square root that, and I get 11 centimeters. And in this case, we didn't actually have to round our answer. It went right on 11. Okay, let's look at a few word problems. The tricky part of word problems with these types of questions is figuring out whether the number you're given is A, B, or C. So I love to start with a picture. So what I want you to do is try this one out, draw a picture to help you, use our formula, and then we will take it up together. Okay, a 6-foot ladder is placed against a wall with its base 2 feet from the wall. How high above the ground is the top of the ladder? And it wants us to round our answer to the nearest hundredth. So here's a triangle. It says a 6-foot ladder. So the ladder itself is 6 feet and it's leaning against a wall. So this is going to be my 6 foot. And it says its base, the bottom of the ladder, is 2 feet from the wall. So I'm going to label this as 2. And it wants to know how high above the ground is the top of the ladder. So I'm looking for this side, which is A or B. And it doesn't matter which one as long as we know this one is C. So here's my formula. I'm going to rearrange for B. And so I get 6 squared minus 2 squared. And then I need to square root this, and I get 5.66 feet when round to the nearest hundredth or 2 decimal points. And because it is a word problem, we always want to answer with words. So the top of the ladder is 5.66 feet off the ground. Okay, here is another word problem I want you to try. Pause the video and start it up again when you're ready. Okay, so again, I always start with just drawing a basic triangle, and then I label my triangle. The slide at the playground has a height of 6 feet, so it's 6 feet high. The base of the slide is measured on the ground is 8 feet. What is the length of the sliding board? So it's asking for C in this case. So I can keep my formula as it is, 6 squared plus 8 squared. And then I'm going to square root that, and I get 10 feet. And again, we write our answer in a sentence. The slide is 10 feet long. Okay, so there are our problems with Pythagorean theorem. I want you to think about how you have progressed throughout this video. If you are a sad face, meaning you really don't understand, you're going to ask your teacher for some more problems or help. If you are a thoughtful face, meaning you're sort of there but you need some more practice, you're going to do the assigned practice problems. And if you are a happy face, meaning you completely understand, you get it, I still suggest trying a few of the word problems or a few of the practice problems to make sure it sticks in your brain, and then you're good to go on to the next topic.